fun would a midterm be if we didn't have some Python on it today? So we've covered an awful lot of Python. In fact, I seem to recall that your toolbox that we put together has a bunch of stuff in it. Take a look and see what you already know about. Well, you know about the print statement. You know about math, strings, input and output, if then else, elif, or good for an elif, while, for, and of course, our recent addition to the toolbox, our buddy Mr. Lists. I would say they are all candidates to show up on your midterm. So let's go stepping through these and see what we've got to figure out. So remember our first program back in the day? Well, our first line in our program started with a hash mark and it said my first Python program. What does a hash mark mean? It's comment, right? Everybody's going to process it. See the hash mark, throws the rest away. Next came print, left paren, double quote, hello world, double quote, right paren. Who? Your buddy, your pal, Mr. Print statement. Okay? And what did this print out? Hello world, right? That's all there was to it. Okay? Print function syntax is we start with the word print. Can I put capital letters in print? No. It all has to be lowercase, right? I thought pretty strict about that stuff. Then we have a parentheses, anything we want that's a string in there has to be in quotes. Commas separate things that we want to print out. Can we put numbers in there? Yes. Can we put math expressions in there? Sure, go ahead, no problem whatsoever. Okay? Then we could also put something else at the end in quotes if we wanted to. So we can do all sorts of fantastic and wonderful things inside of our print statement. And where does the print statement output go? Right on the screen. That's exactly where we want to see it. Let's talk about variables. Variables, that's where we like to store stuff while our program's running, right? Reserved memory locations is exactly what they are. We love that. That's very good. Variable names in Python, you can call it pretty much anything you want. One thing you can't do is start a variable name with a number. It can't be a digit. So it can be an underscore or it can be an alphanumeric letter. That is fantastic. Okay? Do we have to tell Python about a variable before we start to use it? Do we have to say it's going to be an integer, or it's going to be a float, or it's going to be a string before we do anything with it? Python's very cool language. Hey, you know, whatever. If you start to use it, I'll figure out what you want it to be, right? Very cool stuff, right? Operator to the left of the operand is the name of the variable, and everything off to the right is whatever you want to assign it to. Examples are counter equals 100, miles equals 1000.0, and name equals double quote John double quote. So counter would be what type of variable? Integer. Miles would be what type of variable? Float. And how would you know it's going to be a float? Decimal, exactly. And name would be what type of variable? A string. Exactly. Python math. We love math. Python loves math. A plus B does what? Addition. A minus B does what? A times B is? And A slash B is what? Division. Fantastic. Now that's all the normal stuff. Now let's talk about the freaky weird stuff. A slash B is what? It's actually called floor division. Okay? And what does it do? Well, 5 slash 2 is 2. Basically, if you divide something by another number, you get like the primary number and you get the remainder. Floor division gives you the primary number and throws away the remainder. But that's okay because we've got modulo. What does modulo give you?
Remainder.
Exactly. And what is, how do we do modulo? What's the symbology for modulo? It's a percent sign. So number, percent sign, number is modulo, right? Got that? Now remember, I love modulo. I really love modulo. Could it show up in the midterm? Maybe. Because I do really love modulo. Alright, negation. How do we do negation? We just put a dash in front and poof, so it is negative. But that's fine. If we want to make something positive, we use what's called absolute value, or ABS. Gotcha. We want to raise something to a power. How do we do that? Square something. I want to square something. How do I do it? Star, right? Or 100, or 200, or whatever. Okay, cool. Alright. Modulo, it's your friend. Manhunt is 113 cans of Coke. He has a group of boxes that can hold 12 cans. How many cans will he have left over? How would we do that one? I got all these boxes, they hold 12 cans. I got 113 cans. The question is, obviously 113 can't be divided by 12. Got it? So how many cans am I going to have left over? So how do we do this one? We do... And if I was writing that out in Python, what would that look like? There you go. You got it. Rock and roll. Okay, what's come? Ooh! This one just smells like a midterm question, doesn't it? So in other words, in Python, the way you evaluate a mathematical expression depends on the operations, right? So if I had a whole bunch of math stuff stuck together, Python's going to step through that and evaluate it in a very specific way. And remember, the key phrase is, please excuse my dear Aunt Sally. Please repeat that after me. Please excuse my dear Aunt Sally. And that stands for parentheses, which get evaluated first, exponents, multiplication and division, and then finally, addition and subtraction. What does that actually mean? Well, okay, one of the first things to get taken care of is 3 squared. That's one of the parentheses would be first, that would be number 2. Negation would come next. Multiplication and division, okay, we'll do those actually. So, look, here's one. 2 plus 3 times 4 divided by 6. So how's this one going to get evaluated by Python?
3 times 4 divided by 6 plus 2.
That's exactly right. So let's just make sure that everybody's on board here. So 2 plus 3 times 4 divided by 6. If I'm Mr. Python, I'm coming along, like 2 plus 3, okay, that's cool. Oh wait, 3 times 4. Do I do multiplication before addition?
Yep.
So 3 times 4 is what? Sorry, it was what? 12. Now the next thing is the division. Do I do the division before the addition? So 12 divided by 6 is what? So 2 plus 2 is, there you go. Alright? So knowing what order Python evaluates its mathematical expressions in is always a critical thing for you to know. So we just remember, please excuse my dear Aunt Sally, and you'll be good to go. Precedence rules, okay, simplify this, so that, now, so here's another one. 4 plus 2 plus 1, so obviously we do the parentheses first, which is 3, we square 3. 3 times 3 is 9, plus 4 is going to be what, 13? We're good to go. And then we go through and do the rest. Not all numbers are created equal, so we talked about this. Integers, we know integers, 1, 2, 3, 4, 5, 6, fantastic. Real numbers or float numbers are 1.25, 0.37, 101.2, cool, we know about that. Those are basically our floats. Mixed mode, okay, so we can always convert things. So determine the type. Type tells us what type we're dealing with, integer or float or something like that. Drop the decimal, integer, so if we do int, 3.5 int gives us 3. Okay. Round up, round down, so that's a round. Change to decimal, float. So if I have 1, I do a float on it, I get 1.00. That's it. Okay, change to a string, str, paren. So if I have a 5, do a stir on it, and all of a sudden I get quote, 5, unquote. Cool kid stuff? Oh, I love cool kid stuff, don't you? This is just the neatest thing in the whole wide world. Okay, so if I have sum plus equals 1, what does that actually mean?
Keeps adding.
Sum equals sum plus 1.
Exactly, right? So another way of looking at this is it's just a shorthand way of writing sum equals sum plus 1. That's all there is to it, right? Okay, we can also do sum minus equals 1, which is sum equals sum minus 1. And then we got the fancy e notation, which is 1e to the 6th is the same as 1 times 10 to the 6th power, which is the same as 1. What is that saying? 1. Okay. Strings! We love strings! What are strings? Strings are basically a whole bunch of characters stuck together, right? How do we deal with strings? We say answer equals quote, quote, A. That's fantastic. A string literal is a whole bunch of letters stuck together, like Mississippi. And we can do single or double quotes. So double quotes, fire truck, or quote, quote, fire truck. Python doesn't give a darn. As long as if you're doing double, end with a double. If you're doing single, end with a single. Python's taken care of. Strings and characters. Oh, yeah. So this is a little subtlety of strings. So if I've got like a word or a name or something like that, I can treat it as a word or a name. We got no problems with that whatsoever. However, there's another way we can look at it, because we can actually index into it. So each letter in a string we can access individually, starting from what number? 0. 0, 1, 2, 3, 4. We can grant to each and every single one of those. That is absolutely fantastic. So if I've got a little buddy tiles here, we want to say name equals tiles. Fantastic. We're good to go. Length of name is 5. But the positions go from 0 to 4. That's exactly right. That's important stuff. Remember, we're talking about Python stuff here. If I say name, square bracket, 0, square bracket gives me what letter? Excellent. I do name, square bracket, 4, square bracket gives me what letter? There we go. Indexing into strings. Not rocket science, you just have to understand how it works. All characters have numbers. Ooh. Yeah. So this one's actually fairly important. You want to pay attention to this one. Okay, so what we're talking about here. So what we're talking about is the fact that characters have a numeric representation in the computer, right? And you can zip back and forth between this. I think you used this on one of your homeworks, didn't you? Okay, cool. All right, so you're already sort of there on this one. Let's refresh your memory on this one. So basically a number can be translated into a letter, and likewise a letter can be translated into a number, and the secret numbering system that we use is called what? The ASCII coding system, exactly right. Okay, so how do we do this? There's two functions you need to remember, keep tight in your brain. The first one is called ORD. ORD takes a letter and cranks out a number, right? So ORD of capital A is 65. Well, fantastic, that's great, that's a wonderful question.
Do you need the quotes on that?
You do need the quotes around that. I could also stick a variable in there though, right? So I could say letter equals, quote, A, unquote. And I could do ORD of letter, and it would be 65. Okay, so yes, if I do have a string there, I do that. And ORD can only handle one character. So I couldn't put Mississippi in there. And the ORD would be like, what? You can only handle a single character at a time. That make sense? Gotcha. So you can use OR to turn a letter into a number. Seems like you should have the ability to turn a number into a letter, right? Good news. That's what CHR is all about. So CHR says, give me a number, and I'll give you the ASCII representation of it. So if I give you 65, I'll go ahead and give you A. Are there any questions about ORD or char? Numbers and letters have a relationship. ORD and char is how you flow back and forth between them. Make sense? Input and output. Yay, we love input and output. So the input statement says input, quote, then some text that's supposed to be displayed to the user. User puts in their input. Great, that's fantastic. And then it's going ahead and we stick it into a variable over here. First equals input, blah, 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 blah. What's the interesting characteristic of all input in a Python program? It comes in as a string. Ah, you can ask for a number, that's great, but it's still going to come in as a string. That's exactly correct. So that's what we see. Boop, we're good to go. So what happens is, num bottles equals input. Please enter the number of bottles. They typed in some fantastic number, but it comes in as a what? String. So what we have to do is we have to convert it. So we say int num bottles. We actually put the number in there. So if they entered 100 bottles, come in as a string. Put int around it, it's going to convert that string into a number, we're good to go. If it's a fancy thing, it's got a little decimal point in it. Input, enter price per bottle, goes into bottle price. Then we do float, bottle price, that's going to go into price. So we'll convert that string with the decimal point into a floating point number. And we'll go ahead and shove it into price, and we're good to go. So we're able to flow between strings and integers, and flow between strings and floating point numbers. Fantastic. Ooh, our old friend formatted output. We like formatted output, don't we? Not that hard to do. It's our old friend. Okay, so how do we do this? So basically we have a print statement, and in the print statement we got everything between two quotes. In the print statement everything's cool, but then we have some of what are called format specifiers. We know it's a format specifier because it starts with a percentage. Da-da-da. After the percentage comes something like a D, or an S, or an F. And what does that actually mean? What should be put there if it's a D? Exactly, and if it's an F? Or how about an S? That is exactly correct. Now, things can get a little bit funky. 10.2F. So what's going on there? Percent, which means that we're going to do a format specifier. Okay, that's cool. But then we had 10.2F. So what's going on with that? What does the 10 mean? 10 spaces, so we're having like a window, so to speak, to print the number. It's going to be 10 wide. What's the 0.2 for? After the decimal point, we want to reserve for 2. So basically, in that 10, how many spaces have we already used up? 3, right? Because 1 for the decimal point, 2 for the to the right of the decimal point, which means we now have exactly how many spaces left to print our number? 7. That's it. That's all there is to it. Okay, so we have all of this. Then we have a percent sign. And then in parentheses, we have the variables that we want to load in back into that print statement. That make sense? No rocket science. So you had to do this in your homework. You also have to do left justification to do what, a dash or whatever, and to do right justification is what it normally does. So this is old hand stuff for you. No problems for you. You're bright and smart. Great. So here's just a little example. Title 1 is quantity, Title 2 is price, print, percent dash 10S, percent 10D, Title 1 24. So what do we get? We get quantity 24, and I think quantity is left justified in the case, yes. And same thing here, price is left justified, and that's what? 10.2. Okay, so it's a 10 and 0.2, so we got 2 afterwards. This is more of what we're talking about. Especially percent D does a decimal, percent 5D does 5 spaces in a decimal, percent 05D, if you care, would actually fill in zeros, and the rest of it's there also. Okay? Our buddy Mr. If. If statement is designed to implement a decision. Is this condition true? If this condition is true, then go ahead and execute this set of commands. Fantastic. So what does this if statement look like? If, then we have a condition, then a colon, right? And then one or more statements that get executed if the if statement is correct. Now, potentially, you don't have to. But if you choose to, you can have an else statement followed by a colon and a bunch of conditions that get executed if the if statement was not true. So remember, your buddy Mr. If statement comes with his pound Mr. Else statement, and you can cover the true or not true statement all in one thing. After this all gets done, you just keep on executing as though it never exists. All right, tabs. Oh yes, remember in Python, everything's all about tabbing, right? So if total sales is greater than 100, tab in 1, 2, 3. What this tabbing means is that these 3 statements get executed when that if statement is true. Now we're going to pull it back out, else. That means the else is associated with that particular if. And then there's tab, 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 pulling it all in. Notice that we also have an if statement. That if statement we tab one more time, indicating the print is associated with the if statement, which of course is associated with the else statement. Tab, 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 white space all over the place. Python, they use tabs. Relational operators. Again, this is the important stuff. Okay, so the little caret going to the right is a what symbol? Little symbol going to the right, and an equal sign is? Bingo. Little caret symbol going to the left is? Less than. Little caret going to the left, and an equal sign is what? Freaky weird double equals. Still equal. It means equal, right? Freaky weird exclamation equal. Not equal. Not equal, right? Seems like that's sort of critical to know. So I think you might want to tuck that away just to remember what's going on. Example of relational operators. Okay, 3 exclamation equal 5 minus 1. Well, what's 5 minus 1? That's 4. So is 3 exclamation equal 4? Is that a true statement or a false statement? False. It's actually a true statement. No, 3 is not equal to 4, right. Is that right? All right. How about 3 equal 5 minus 2? What's 5 minus 2? And then 3 equal 3 is true. Bingo. There you go. You know everything you need to know about that stuff. Oh. Nested branch. Oh yeah. Okay. So remember our club example? So we show up at the club. Hey, yeah, cool. Is it too full? No, it's not too full. Are you on the VIP list? Bam, you're right in. Sadly enough, show up it's too full. You're gonna wait in your car. When it's not too full, then poof, you're gonna go ahead and wait in line. So remember, nested if is just simply an if statement with another if statement inside of it. And you can do that until the cows come home. Example of a nested branch. Okay, so if people in the club, it's less than max people. If your name is on the VIP list, you go right in. So there's your nested if statement right there. And you can nest your else statements and all that sort of stuff too. Lots and lots of comparisons. Problems with super nesting. It's difficult to read, shifted too far to the right, so there's got to be a better way to do this stuff. What would that be? Dun, dun, dun. Our buddy Elif. Yeah, you remember Elif, right? If class score is greater than 90, then hey, you got an A. Oh, Elif, which is basically like a whole brand new if, but it's assuming that that one was false. If assuming that that one was false. If class score is greater than 80, hey, you got a B. Hey, that's great. Wait, there's another Elif. 70, 60, boom, all the way down, right? So Elif is just like another if statement, but it's assuming that the first if statement was false. How do you do things over and over and over and over again? Ah, it's our buddy Mr. While's statement. You remember Mr. While's statement? While, condition, do all this sort of stuff, right? So it is a That is correct. Okay? As long as the condition remains true, the statements while are executed. Okay. How can I use a loop for a given number of times? Remember, a while's got like a condition, so it doesn't really count things per se. But you can actually do this pretty easy. Counter equals 1, while counter is less than or equal to 10. Print counter, counter equals counter plus 1. So basically, if you use a variable, you can make a while loop execute a very specific number of times, which might be what you want to do. The for statement, sort of like the while loop's second cousin, so to speak. For letter and stating. So is while the variable is in the thing that you're talking about, colon, print letter. All right? So we can go stepping through a string, right? So while whatever in Mississippi, we're stepping through, we have individual. We can also do that range thing. What's the difference between a while loop and a for loop? In the for loop, the element variable is assigned the state name 1, so on. In the while loop, the index variable is assigned 0, 1, so on. So basically, the for loop, we go stepping through 1, 2, 3, 4, 5. In a while loop, it's condition, 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 condition. Our buddy, the range function, you remember range function, right? Okay. So it's how we count control things. For I in a range 1, 10 means I will take on what values? 1, 10 means I takes on what values? 1 through what? 9. Remember, careful. Range has a secret little thing. Does it actually go up to the maximum number? No. No. It's 1 less, right? That's exactly correct. Okay? You can do the same thing in while and for loops. For I in range 1 through 10, print I equals 1 while I is less than 10, print I. So remember, in the while loop, we'll never get up to 10 either. We'll get up to 9, then we'll be done.
We can set it
You can set it to anything you want.
equal to 10.
You certainly could. And you can pop this up to 11, right? You can make it to 11. So a lot of 6 different ways to skin the thing, same exact, right? Stepping out, just to remember, so for I in range 1, 10, 2. The little comma 2 means that we're going to go stepping through in increments of 2. So it'll be 1, 3, 5, 7, 9, out. Okay? So remember, our buddy Mr. Range has 3 different flavors that he comes in. For I in range 5, just a number. What it really means is 0 to that number minus 1, right? For I in range 1, the number, it will start at 1 and it will go to the number minus 1. And our third crazy example here is for I in range 1, 11, 2. It means we would go up to basically 10 in increments of 2. Secret form of a print statement, print value, 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 comma, n equals quote, quote, and what does that cause to happen? Stays on the line, right? We don't go to the next line. 4 steps to creating a Python list. Our buddy, Mr. List, right? COP2271C, Introduction to Computing and Programming 3. The very first thing we did is we put quotes around each one of those strings. COP2271C, Introduction to Computing and Programming has quotes, and then 3 does not have quotes because it's a number. The next thing we did is we stuck a little comma in between each one of the items. So one of the 3 items showed up. Then, this is where it gets crazy, we put square brackets around these little buggers. Ching, 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 ching. That turned it actually into a list, and then we said, what the heck? A list in space isn't going to do us any good. So we put a variable over here, prerequisites equals square bracket thing, pow. Then all of a sudden that list was associated with the variable prerequisites, and all of a sudden we had 3 items that had been stuck into one particular variable. How to access it after we've done it? Well, we used the little square bracket guy, just like we did with the characters and strings and stuff like that. So we can do print values square bracket 5. What that means is that we'll reach into Mr. Values, and in your and my speak, we'd actually go to position number 6, 0, 1, 2, 3, 4, 5, and we would pull out whatever happens to store there. Remember, it could be a number, it could be a string, it could be an integer, it could be a float, it could be another list. It could be just about anything. Access your data list using the square bracket notation. Print prerequisite square bracket 0 came out to be COP2271C. Print prerequisite square bracket 1 came out to be the title of the class. And print prerequisite square bracket 2 came out to be the number of credit hours associated with the class, which in this particular case was 3. So we're able to reach into a list and pull out each and every individual item in there. You can create, oh my goodness, multi-dimensional lists, rows and columns, which in the world of Python is basically a list of lists. So multi-dim equals square bracket, up, square bracket 1, 2, 3, square bracket 4, 5, 6, square bracket 7, 8, 9, square bracket, boom, and it produces this. Basically 3 rows and 3 columns. And playing with lists, we can go ahead and we can append stuff. Remember, append sticks stuff on the back of it. It's almost like a car crash. Pow, taken care of. We can pop things off. You do pop without a number, then it just removes the very last item on the list. You do pop with a number, it'll remove that particular item within the list off. Goodbye, say pop. We can remove, so if you know exactly what you want to get rid of, in this particular case, sadly enough, it was Dr. Anderson. We went looking into our list, we found it, and we pulled it right out. It didn't really matter where it was located. We also can do insert, and what's cool about insert is we can stick it in a particular location. So we specify the location in the list. This is position, basically near my vocabulary 3, but they call it position number 2. We're going to stick the string really hard. Pow, just stick it right in there. We're good to go. Right? And now we'll give our example. 0, 1, 0, 1, 2. Pow, really hard to there, and then 3 gets pushed off too. Extend. What extend does is it takes a list and it adds it to our list. So it's list plus list. Fantastic. So we already had this list, but now we took this list, Dr. Anderson in 2015, and we stuck it onto the end of it. Poof, we're good to go. How cool is that? How to access the list. Okay, we'll already talked about this. I think, yep. Add this in there twice. Yep. Okay, cool. Oh, good. Good news. It did not change. All right, appending elements. All right, start with an empty list. Yay, got nothing in there. Then we go ahead and append it. Use the phrase append burgers. Pow, now good food has burgers on it. Ice cream, hot dog, and cake. Travis taken care of. Inserting elements, we already talked about that. This is how we got Cindy to be inserted into our list of friends. Fantastic. Finding an element, if Cindy in friends. Okay, fantastic. So you can go searching a list by simply just saying, is it in there? If you know the particular position, friends.index, look for the string. It will actually return what location in the string it happens to be located at. And by the way, if it's located more in one place, you can certainly find it there too. Removing an element, we've already talked about pop. Tables, we know about tables. This is where we set up our medal table. Remember we did all this sort of stuff like that. We went in and found out who won how many gold medals and stuff like that. Accessing individual ones. Now this is something that some people are struggling with, but it's like double indexing, right? So the question is, what row, top to bottom, I'm here, and then what column? I'm actually on the second one, 0, 1, pow. Now I can pull that item out of my particular list, okay? So I have a multi-dimensional table or a list of lists, and I have to have 2 indices. In this case 3, I have 1. That make sense? Okay? That's it.
Hey.
That's everything. We covered everything that we covered in the class. It's all in your head right now. How cool is that? Now remember, these slides are already on Canvas. They should be available to you if you have any questions. If you have any questions, you can send me an email. Questions?